Hi, welcome. In this video, we will solve problem longest repeating character replacement asked by companies like Amazon, Microsoft, and Facebook.
Now let's check out this problem statement, longest repeating character replacement. Okay. Again, this problem is on the basis of two pointers and sliding window. We will solve it. And again, this is the problem that comes in many interviews because this is again a fundamental problem on sliding window technique, right? So in general interviews, in general companies, you will see a pattern of the questions will be comes from two pointers, sliding window, stacks, queues, and linked list. So now let's quickly go through this problem statement. So you are given a string s and an integer k, and you can choose any character of the string and change it to any other uppercase English character. Okay, you can perform this operation at most k times. So we have given, that's why k. Return the length of the longest substring containing the same letter you can get after performing the above operation. So let's understand the problem statement. So we need to return the longest substring. Okay, what is substring? Basically, substring is the part of the string. Okay, and containing the same letter you can get after performing the above operation. So what do you need? What is the above operation? That you need to change to any other case English character. Okay, so here you can see this is one input A, B, A, B, right? This is one string S, and the operations that are allowed, that is 2. So what we can do? We can change at most 2 characters of this string, and then we can get the longest substring containing the same letter. Okay. So if I am going to change at most 2 characters of this string such that so that I will get the longest substring containing the same letter. So what I will do? I will change this A and this A to B. So this will be B, B, and I will get this as a length of 4. So that's why the answer will be 4. Okay. Let's check out this problem statement like this example here. So we have A, B, B, and A. Okay. And here the K is 1. That the only allowed character that you can change to uppercase English character, that is only 1. Okay. At most 1. So what we will do? Okay. We will again find which character we can change it. And if I am changing this character to B, right, will I get the longest substring containing the same character? That is continuous. Alright. Will I get it? No. So I won't change it. Okay. If I change this, what will the longest consecutive? Here, this will be the same, right? Longest consecutive substring. So like this is not greater. Okay. Only size of 2. And if I am changing this character, the middle one, A to B, okay, what will the length that I will get? The longest substring I will get containing of the same letter, right? It will be B, A, B, B, sorry, B, B. This will be the maximum length, 4, and that's why the answer 4. Okay. So you can check it, like if you are changing any other character except this one, right? Not this one. You are changing any other character, you won't get the longest. Okay. Suppose you are changing this one, right? So this is A, right? So again, the maximum length is here, that is 3. Okay, not 4. So this is the only case here we are getting the maximum substring or maximum size of the substring containing the same letter. Now let's see how we can solve this problem statement. So I have a string. Okay, let me mention this string as we have A, B, then B, we have C, B, B, A. Alright, this is the string, and let's see that K we have equals to 2. What is the length? That is 2, 2, 4, 5, 6, 7, 8. So the length of the string, that is 8. Now let's quickly check out what will the answer of it when we are allowed to do 2 operations here. What will the answer here? So I have 2 possibilities, right? So if I say I have 2 possibilities, either I can change this character C and this A character. So I will get B, 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 B here. Okay, the maximum length will be 5 in this case. Or what I will do, I can change this C character and this A character. So if I'm doing this, but I will get maximum length here, that is B, 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 right? Here we are getting 6 character. Let me check. Yes. So like in the last case also we were getting the length 6, not 5, right? So in that case also we were getting 6. So the maximum answer that we will get here, that will be the length of 6. Okay. So now let's see how we can solve this, problem statement. Okay, let me put here and let's figure out what could be the approaches, how we can solve this problem. We have n equals to 8, k equals to 2. So the first approach that we can apply here, the brute force, and I will say that will be the extreme brute force, right? Naive approach here. Okay, that like whenever there will be a strings, right? Whenever there will be a string or sequence of numbers, the in the brute force, what you can do, you can generate all possible substrings, right? The only thing that you can understand, that you generate all the possible substrings. So like I will generate possible substrings A, then A, then A, B, and then A, B, B, and then A, B, B, C, something like this. I will generate all the possible substrings. Okay, now when I'm generating all these substrings, now let's see how we will get to know what, like which letter that I need to change it, right? It can be either A or B or C. So which letter I need to find out that I need to change it. Okay, so suppose you got a substring. Okay, you got a substring. Okay, you can take any of these substring, like here you can take, let's suppose A, B. Okay, so we have A and B, right? So what could be your approach? Like what do you think, which letter should we change, right? Okay, so we have two letters here, either A and B. The frequency of A is 2 and the frequency of B is 1, right? So which letter should we change? I will change the B, right? I will change the B. Why? Why? Because I have limited number of operations, right? I have limited number of operation, K is 2. So what I will do, I will try to change as minimum as possible, right? My change should be the minimum, right? Whenever I am generating a substring, okay, then the letters, the characters that I need to change should be minimum, right? So what I will do, I will say that what is the total length here? Total length of the substring, that is 3. Okay. What is my maximum frequency here? That is 2. Okay. And so what are the change? What change I will do? Okay. So I will take length minus maximum frequency. Okay. So 3 minus 2, I will get 1, and I will change the one character. Right. Always the lower part. Always the lower part. Let's check out one another example here. Let's suppose you are taking this example AA and BB, right? So here both the characters have same frequency. A is also 2, B is also 2, right? What is the length? Length is 4. So length minus maximum frequency, that is 2. 4 minus 2. You can change the two characters here, right? And any two, right? Any two you can change it, right? And now let's suppose if I'm taking this case, we have AAB, AABBC, right? What is the frequency here? That is A2, B2, C1, right? And again I will check what are the, like which character I will change it, So length minus maximum frequency, that is, what is the length? That is 5 minus maximum frequency 2. So I will change 3 characters here, right? Either this can be 3 or AAC, right? And suppose instead of this, right? Suppose instead of AABBC, the characters is something like this: A, then BC, right? So the maximum frequency will be 3, okay? And what you will get? You will get the length 5 minus 3, that is 2. So these will be the two characters that you will change. So from this you will get to know, like what is the number of characters that you are going to change, right? You won't take the maximum, right? Here you won't take the A, right? Because these are more in numbers. Okay, so if you are like the same example, you can do it like this. You can change it like this: B, B, B. right? But how many operations you have done? 2 to get the consecutive sequence here, right? Not consecutive, I will say longest substring containing the same letter, right? So you got the longest substring containing the same letter, but the operations required it here too. And if you are changing by this one, okay, A, 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 A. So how many operations you got here? Only one, okay? And you did only one operation and still you are getting the same result. So the concept of L minus MF is cleared, I guess, here. So basically, find this length, like whatever the length is, what is the maximum frequency, okay, and then these would be the change of elements that we will do, okay. So the basic approach will be here in the brute force that we will generate all possible substrings, right, like A, B, B, C, and then the next substring we will get like A, B, B, C, B, right, like this. And then what we will do, we will take each element, right, take each substring, okay, we will find what are the characters that we can like what are the characters that we can change it. So like here, if I'm taking this example, AAB, okay, I will take, sorry, let me write it AAB. So if I'm taking AAB, so how many characters that I need to change it? Okay, that is one, that is under K. Okay, so I can do it, and I will, what I will do, I will simply find the length of the, I will store in my maximum the length of the substring. Okay, then I will take A, B, B. Okay, what are the characters that I need to change it? So again, what is the length minus maximum frequency? So 4 minus 2, that is 2 characters I can change it, and 2 is under my K, right? So I can do it. So what will the length here? What will be the length here? That is again 4, right? So we will say 4, and then we have A, B, B, C, right? So what will be L minus MF? That is 4 minus, sorry, 5 minus 3, right? Because 5 minus 2, because the consecutive, the maximum frequency here we have 2. So 5 minus 2, that is 3. And 3 is greater than K, right? 3 is greater than K. So what we will do, we won't take it, right? We will again generate a new substrings, and like this we will solve it. So if I write a brute force approach of this problem, okay, that how we are going to do. So what I will do, I will simply take one object here. Again, this is my approach one. That is the brute force approach. What I will do, I will take one object, okay, and I will take one maximum frequency with 0. Then I will take maximum, okay, that is the maximum size of the substring, okay, of same characters, okay, that will also start from 0. And then I will take one for loop where I will start from 0 to n, okay, this will be my one for loop. Inside for loop, I'll simply say my maximum frequency always will start from 0. My object will start from 0. Okay, so why I'm taking object? Object is basically to store the frequency, right? You can take set, hash map, whatever it is. Okay, so I will store in the object. Now I will generate all the possible substrings. So I will generate possible substring from I to n. Okay, and what I will do, I will simply store the frequency, right? So I will say that I can map in my object, or you can simply write it like your object frequency. So object of S of J, right? You will mention. So there will be two cases, like if object of S of J is not defined. So what you will do, you will define it with 1. And if it is already defined, what you will do, you will update the frequency. Okay, update the frequency. When you are doing it, okay, you will also take a count of maximum frequency. So you will do math dot max, okay, of your maximum frequency and the current element frequency. Now, so when you are doing, so let me add the same example. So let me copy this one, paste it here. So when I'm taking this example, right? So what I am doing here, I'm generating all the possible substrings like A, then A, then AAV. Okay. So all these strings will come here. I will get like here for this string, I will get maximum frequency of 2, right? So I will get maximum frequency of 2 that will stored in my object like something like this A2, B1. Okay. And what I will do, I will find that is this is a possible case or not, right? So what is K? K is 2, right? So what I will do, I will find the length. How I will find the length? I have J and I pointer. So what will be the length of the substring? Okay, that will be, and I say that will be J minus I plus 1. This will be my length of the substring. And now I will subtract the minus MF, right? That is maximum frequency. Okay. So I will subtract it. So I will get the count, that letter that I need to change it, right? So this will be the single letter that I need to change it. Change letter. Okay. That will be J minus I plus 1. Now I will check if the change is less than equals to K, right? What I will do, I will store it. I will store in my maximum that method dot max of the max and my J minus I plus 1, right? Or you can simply say this J minus I plus 1 is your change. So you will mention change here, right? And suppose if this case is not existing, right? If this case is not existing, so what you will do, you will simply break it. Okay, you will break it here and your I pointer will move here and again new strings will form, right? You will form new substrings A, B, then A, B, B, and again same case, right? So, right, this else will come under the for loop. This else will come under the for loop and this will be the ith, and in the last you will return maximum. Now let's talk about the time complexity of this approach. So this loop is running for n times. Okay, here this is running for n time. Okay, so for each string, like for each character, you are finding all the possible substrings, right? So it is n and n. So the time complexity will be big O of n square. Okay, and we are not taking any extra space, but yeah, we are taking one extra space, that is object. We are storing elements in the object. So if I am taking all the elements are unique, if all the elements are unique, so in the worst case, the space complexity will go till big O of n. So this will be the time and space complexity of your brute force approach. Okay. So this was the brute force approach, the extreme brute force naive approach that you can imagine. And again, like this is why it is taking a very good amount of time. That's why the time complexity is big O of n square. Your interview won't be impressed by your this solution. But yeah, again, like you can always start brute force approach because you get some idea. You got this thing, right? Always, like all the approaches. Okay, this is about building the logic. Okay, whenever we build the logic, we got some few steps. So when I am trying here brute force, I got this thing, right? How I will find my string is valid or not. Okay, so how I will find that the substring that I am generating is valid or not. So that is the length of the string, okay, minus maximum frequency. If it is less than equals to K, okay, that means it is valid, right? So basically what I am checking length of the string minus maximum frequency. What we will get? We will get the characters that I can change it. Okay. And if the characters that I can change it is under K, can I say that this is a valid string? Yes. So from this brute force approach, we got a hunch, we got a hint that this is how you can judge a valid string. Now let's see the next approach, that how we can optimize our approach. So let's see. So here, so let's see here, this is my string. Okay, A, B, B, C, B, A, and what we got as an answer? The answer was 6. Okay, what is the length? The length is 8 and the K is. So what we will do, instead of generating all the possible substrings, right? We will do the same as we do in a sliding window, right? We will take out the window here. Okay, and how is the window? We will get it like this. Window will be the valid substring. Valid substring. So what I'm saying, that window is a valid string. What is making this sense? So I am saying whenever you are going from a valid to non-valid, okay, non-valid substring, you will stop it there. You will stop there. Okay, and then you will try to remove the letters from the beginning, and that will be your window. So basically what you will do, you will start from a window and you will increase your size. Like here I have started from, suppose this a character, I will increase my window size. I will continuously increase my window size again and again. Whenever I am falling into a non-valid zone, what I will do, I will try to remove the letters. I will try to remove the letters one by one. So here my window will increase first, okay, increase first, and then it will decrease. Okay, then it will decrease like this. So this is what we will do in this approach here. So what I will do, let me remove these things and let's mention this thing. So I will create an object or a hash map to note down the frequency. So let's create an object. So this is my object. Okay, again in the form of key value here. So what I will do, okay, I will take each letter one by one. So let's suppose I will take here A, right? I'm taking first letter. I will simply, so let's see, let's make some pointer. I will take one R pointer, okay, that will move in this direction, and one L pointer. Again, same thing, R for addition, L for removal. So I will take, suppose the first character, that is A, I will put it here, okay, with a frequency of 1. So I will find out few things, right? First of all, ls is the length of the string. What is the length of the string? So if there is only one character, so length of the string is 1. And what is the maximum frequency till I got? That is 1. Okay. So what is the ls minus mf? Okay. Is it less than equals to k? So ls is 1 minus 1, that is 0. Yes, it is less than equals to. Yeah. So move. So what I will do? I will move my r pointer. Okay, I will take again one character A. So the frequency will be now 2. So what will be the length? Length will be 2. Maximum frequency will be 2. Again it will be 0, which is less than equals to k. So again we are under a valid zone. We will simply move it. Okay, now I will got a character that is B. What is the frequency? 1. So what is the now new length? 3. Maximum frequency again 2. Right. It will be same 2. So 3 minus 2, 1. Again we are under k. So again move. I will get again B, that will be 2, right? Now what is the length of the string? 4. What is the MF? That is 2. 4 minus 2. Again it is less than equals to K. Yes, we are in a valid zone. 4 minus 2, that is 2 under K. We are in a valid zone. Again I will move, right? Now I got C. What is the frequency? 1. Okay. What is the new length now? That is 5. Maximum frequency here again 2, right? So now what is the ls minus mf? Let's see. So if I'm doing ls minus mf, the length of the string is 5 is 2, and that is 3, which is greater than k, so we are not in a valid zone. Right? This is not a valid substring. Okay, so what I will do, I will try to reduce it. So what I will do, I will simply omit this character and I will move from here. Right, so when I'm moving from here, okay, now what will the ls? So ls will be changed, right? Now my new length will be from here, right? R to L. I remember my R point is here, R to L. So how I am calculating my ls? If you don't know, that is R minus L plus 1. So R is pointing to 4, L is pointing to 1 plus 1. So my ls is 4. And what is the maximum frequency here? Now A frequency is also decreased to 1. A is also decreased to 1 because we have removed A. Okay. Maximum frequency again 2. 4 minus 2. Okay. What is 2 under K? Right. We are under K. So this is a valid zone. This is a valid zone. we can simply move it. We will move it. If I move it, what will the mu B frequency? That is 3. Okay. And what will be my LS now? So R is changed now. So I change it. So R will be my 5. L pointer is pointing to 1 plus minus 1. It will be 5. So 5 minus MF, that is 3. 5 minus 3, that is equals to 2. Again we are in a good zone, we are in a valid zone, right? Under K, so I will move it. Now what is the frequency of B will be now 4. So let me simply update all the frequency. So we have now A as 1, B as 4, C as 1. Okay, so now what is my LS minus MF? Let's quickly check it. So how I will get LS? That is R6 minus 1. 6 minus 1 plus 1, that will be 6. 6 minus maximum frequency 4. 6 minus 4, 2. Again we are in a good zone. We are under K. Right? So yes, this is also valid. And then we will simply move it. Now we are moving. So we are moving here. Now we got an A. I will update the frequency with a 2. What will be my LS now? It will be 7. Okay, maximum frequency 4. 7 minus 4, that is 3. Now, this is not a valid zone. So what I will do, I will decrease the frequency from here, remove my L point. So A will be now 1, L will be changed again, right? So now new length will be 7 minus, again R minus L plus 1. So R is pointing to 7, L is pointing to 2 plus 1. So that will be 7 minus 2, 5 plus 1, 6. 6 minus 4, that is 2. So we are in a now valid zone here again. And again I will move my R pointer, and that's it. That's the end of the loop. So during movement, right? During movement, we were getting the valid zones, right? We were getting all the valid zones. What were the valid zones? Like 6 minus 4 was 2. That was a valid zone. And we were getting 5 minus 3. That was 2. That was also a valid zone. And yes, so these were the valid zones. Like here we were getting 6 minus 4, 5 minus 3, right? So when we are getting these valid zones, what we will do, we will store the LS, right? We will store the LS. So here you can see what is LS, that is length of the substring, right? So we are getting the maximum length is 6, and yes, this is my answer. This will be my answer. When we are getting valid zones, the maximum length that I am getting, that is 6. So these will be my answers. Okay. Now let's check the quick pseudo code of it. Okay. So whatever I have said it, how I am going to implement in my code. So what will be my pseudo code? I will take R pointer from 0. I will take pointer from 0. I will create an hash map or an object. Then I will find out the maximum frequency starting from 0. And I will find the max variable starting from 0. Okay. And then I will take while loop that will start from R till n less than n, right? Inside this, what I will do, I will simply store the frequency. Say store the frequency in the object, in my object, like so simple code. Be simply I will do s of R, okay, plus plus, right? Simple your frequency wala code. And then I will also update the maximum frequency. So maximum frequency will be max of maximum frequency and your object value, right? Whatever the value, you will store it. So now you just simply stored it. Just simply stored it. And now what we will do, check while we are in a valid zone. That means LS minus MF is less than equals to K, right? So if we are in a valid zone, we don't need to do thing, right? When we need to subtract it when we are not in a valid zone. So let's change this thing from LS minus MF greater than K. Then we will subtract it. So what I will do, what is my LS? Always remember LS is R minus L plus 1. r minus l plus 1. So if my ls minus mf is greater, then I will change it. And how, what I will change it, right? So first of all, I will simply omit this character, right? So how I will omit this character? First of all, I will decrease it from the frequency. Okay. And I will move my L pointer. So L pointer will be L plus 1, and that's it. Okay. And now I need to update my maximum frequency because my maximum frequency will be changed. So I will update my maximum frequency. And how you will update your maximum frequency? So for this case, you again run a loop that will is in your object. So for key in your object, okay, you will check is there any object value, okay, that is greater than your maximum frequency. If it is, you will update it. Okay. And now once this is done, right, this while part is done, whenever you will come from it, can I say that you will under the valid zone? Because ls minus mf is greater than k, you got out from this loop. Okay, so that means you are in a valid zone. And when you are in a valid zone, I will just add one condition for valid zone: ls minus mf is less than or equals to k. So if this is the case, I will update my maximum length. And what will be the maximum length? That is max of r minus l plus 1, that is your ls and your maximum. And in the last, then what you will do, you will simply move r plus plus because you need to move your r pointer. Yeah, this is how you can simply solve this problem statement. And now let's quickly check what will the time complexity of it. So your r pointer will move from 0 to n, right? So this will run for n times. Inside your while loop, we have one more while loop where my l pointer is moving towards n. But remember, when like this both will move separately, like because when your r is moving, your l won't move from like 0 to 7. No, absolutely not. R will move suppose 3 distance, then l can also move. So it always nearly be 2n, like in the worst case, r point is moving till here and l is point is also moving till here. That can be the worst case. So in worst case, we are taking 2n, but again they both will move separately. So here it is taking n times, this will also taking n time, but again this I won't multiply it. It won't be n square. It will be n plus n, that is 2n, that is nearly 2n. Okay. Now inside the while loop, what you will do, you will search for in your object. You will search for new object, and if suppose in your object all the elements are unique, right? All the elements are unique. So what you will do, you will go for n. Okay. But remember, can we directly go for n? Is it so? No, right? Because n can be 1000. But how many English characters we will get? That is only 26. Okay. So in my object, how many characters that I am going to store? A, B, C, D, E. That will till Z only. So in my object, if I iterate, that won't be n. It will be 26 only, right? So it will be n plus n into 26. Can I say this? Okay. And yeah, this is the only loop. This is only if condition. So my time complexity here will be again nearly to big O of n. Even again 26 when there are all characters present. Okay. Again, that's the worst case. So it is again nearly equals to n. 26 because it will be 27 of n. If we can ignore this constant, right? If n is very high, we can ignore this 27 and this will be again approximately equals to big O of n. So the time complexity will be big O of n. What will the space complexity? Okay. Again, what you have as in space, that is your object. So how many characters you are going to store in an object? That is 26. So that will be 26 your space complexity, and 26 is the constant, so I can say your space complexity will be constant. Time complexity will be big O of n, space complexity will be big O of 1. Okay. Now can we further optimize it, right? Is there any way that we can optimize it? So let's think, let's see. So now what we are doing, we are calculating here maximum frequency, right? See, we are calculating here maximum frequency, right? Here suppose we got AA and then BB. So now what we are doing, when we are subtracting it, we are changing our maximum frequency. Let's not change it. Let's not change it. Why I'm saying so? Why I'm saying this thing? So basically, what we, first of all, we are already calculating maximum frequency when I'm adding here, when I'm updating here, I am also updating my maximum frequency of my new character. So whatever the new character will introduce, I will get the maximum frequency, but but I won't change the, like, I won't decrease the maximum frequency. So let it be. Let it be. So what I am saying, suppose my valid zone I got was till here, right? Was till here. So what is the length? Length is 4 ls minus mf. What is the maximum frequency I got? This is 2. So this is 2. Okay. And what will be stored in my maximum? That is 4. Okay. This will be stored in my maximum. Now, can I say that my answer is going to be equal to 4 or greater than 4? Equal to 4 or greater than 4? Right. So if I am simply decreasing it, okay, it will shrink it, right? It will shrink it. Okay, then I will decrease the frequency as well, right? Then it will shrink it, we are shrink it. Let's not shrink it. Let's eliminate only once and move your window by one. Because you know that till 4 minus 2 it is valid. Okay, it is going well. So what you will do, you will shift your window. You will simply move it, right? So we are not going to change our maximum frequency, okay, because we are already calculating here our maximum frequency, right? Whenever there is a new character, we are updating in the maximum frequency. So if we are changing here, right, if suppose there is a, we are changing, we are not going to change our maximum frequency. So we can simply omit this for loop, okay. And because since we are moving in now with a constant window, right, we got four, we'll move with the constant window. And now inside this window, suppose now inside this window, if we are getting ls minus mf, okay, 4 minus 2, that is less than k, okay, we will move it. And if suppose I have increased it, again it is less than equals to k, can I say that this will be my new length? This will be my new length. So this is how I will move it. This is how I will move it. So I will basically do this thing, and instead of while loop we will simply use it one time, okay. So that we will use if condition only. And now we have reduced our time complexity. We are not taking 26, we are not taking 26 here, right? And this will not be in n, so only this go of this while loop will be considered as an n. And so the time complexity gain, like we have reduced the iterations, but the time complexity will be big O of n. Okay, the space complexity will be here your of one constant. Now in the next video we will see how we can implement this approach. Okay, so we will see the code implementation of these approaches.